Hello guys, hello Maxers. Some times ago I started talking about shaders and then I stopped because somehow this is how I am. I always start something and then I stop. But eventually I come back to the topic. So in this case I want to talk again about shaders. And I want to do that also because I created this external GLSL shader editor that lets you edit shaders and create uniforms. It's a bit of an improvement on the jit.gl shader object. So I thought, okay, maybe what the shader is not really clear what you can do with the shader, and so I want to start this. I want to go on talking about shaders. I have two videos about shaders on my channel. I linked them in the description, but mostly I will start from scratch. I'm going to develop this today without the light because this would be a bit too much. So I'm just going to show you how you can displace the vertices of a shape using a shader instead of using jit.gl as we did in one of my previous videos. So let's get started. Okay, so let's get real and let's develop some shaders. Let's start by creating our jit world object. I will call this world 10 and let's say FSAA. As always, erase color. Let's make this black and floating and size 320 by 240. That should be good. Let's put this window here. Okay, so this is our renderer, our jit world context and renderer. So what else do we need? We need we need to save this patch first of all. So let's save this patch. Let's call this Vertex shader and save it to desktop. But then I prefer to put this patch in a folder, and so I will put it here. Then I open the folder and I open the patch. Now what I want to do is to create my GLSL shader editor that you can download for free on my GitHub. I will put a link on the description. And yeah, here it is. This object takes as arguments, it takes the name of the context. It takes the name of the file that you want to create. So this shader.jxs, and then it takes the name of the shader as an attribute. So let's call this shader shady. Now this object created for me all these files that you shouldn't be bothered by them. So if we open these, we have the shader file. There is a bit of utilities inside. There is this 2π defined, 2π, some varying variables. For example, these access the texture coordinates, the light positions, the light colors of our first two lights. But I will talk about these in other videos actually. Today I just want to concentrate on to focus on the algorithm of the vertex displacement. So let's close this file and actually use the editor here that I created with text edit and see what we can do. So actually, first of all, let's create a jit.gl grid shape to which we are going to apply the shader. Scale this a bit, then say that this shader is going to be our shady shader. And this is all that we need. Let's create also jit.gl handle and attach it to the grid shape so we can maneuverate the shape with our mouse. We can move the shape with our mouse. Let's see what we got. So the shader is already applied. If you go here in the fragment shader, you can see that by default, pink color gets applied to the shape. Then you click here and update the shader. So by default, the shape has this pink, the fragment shader applies this pink color to this shape. But what I want to do is to use the vertex shader and to access a texture from the created in Max, access it inside the shader and displace the vertices according to the value that are inside this texture. So let's create a texture, jit.gl texture, button, and let's name this text1, or let's name this my text, and this should be rectangle 0, because I still didn't put the texture to the rectangle inside the jit.gl shader editor, but I will definitely do this. It's really an easy improvement. So this is our texture. Let's create a jit noise just to see if this works. So it can also be, let's actually make it 4 planes. For 32, let's make this 200 by 200. Let's see what we get in. Let's see what this texture is contains. If we bang, contains our noise. Okay, this is super cool. So let's actually access the shader editor and let's create a variable to declare our texture inside the shader. So in the shader editor, it works like this. You choose the name of the variable, the uniform that you want to create. Then you choose the type of this uniform. In this case, is a texture, two-dimensional texture, so it must be a sample 2D, and default must be 0. So you click on the blue area, and uniform gets created automatically and loaded inside the shader that you choose. In this case, the vertex shader. So let's actually apply the texture to the grid shape, because we need to apply the texture to the grid shape in order for the shader to read it. Does it say? Yeah. Say that is unable to be in the texture because we declared this as a uniform, but never used inside the vertex. So let's actually use it. So let's create a float variable called noise, and this is going to be the value, just one plane of our texture. So let's say we need a texture 2D, and we need the name of our texture, text0, as we declared it as a uniform inside the shader. And then we need the text chord 0 that I provided here as a varying variable. So we can also use this in the fragment shader. And they are declared here. This is a built-in uniform. Actually, it's a built-in variable. This GL texture matrix 0 and GL multi-text chord 0 are built-in variables. We are going to talk about these in other videos. So let's actually access just the X component of this. So the first plane of this texture, since I just want a float variable, so I just access one component of this texture, one plane, and then let's say that we want also to access the position of the vertices. Let's actually add more vertices to this shape. So dimension 200 by 200 for this grid shape. So it's going to have 200 for multiplied by 200 vertices, and so it will be a bit more resolution on the displacement of the vertices. So then we need to create the normals. We need to access the normals for this shape. The normals are automatically created by the grid shape object. They are contained in the matrix that gets outputted from the grid shape if you put the matrix output 1 attribute. So the normals are generated by default by the grid shape or contained in the grid shape. So we are going to access them in the shader, but we need to transform them in I coordinates. So there are different coordinates fields when we talk about OpenGL, and I will cover these also in future videos. So just bear with me. We have the normal matrix that is going to transform the normals in I coordinates, and then we need to access the normal for this specific vertex, because the vertex shader works one vertex at a time, exactly like GTL works one pixel at a time, and jit.gl works one cell of the matrix at a time. The vertex shader works one vertex at a time. So we have now the normal scene I coordinate space, I coordinate normals, and then we also need to normalize those normals. So let's say normal is equal to normalize normal, which means that the magnitude of this normal will always be equal to 1. The normal vector will always be equal to 1. Then let's multiply the normal for the noise. So let's create a new variable called normal noise, and this will be equal to the normal multiplied by the noise. So what are we doing here? We are getting the normals. We actually do something like this. So we are taking the normals, which is a vector that is perpendicular. It's a vector that goes perpendicular to the surface, and the noise is just scaling this vector now, because it's a floating variable that has a random value, so it's just scaling these components. Some component will go much wide, some will be low, will be small. They are just going to be multiplied by the noise values that are random values. So let's close this program. Yeah, save. Okay. So we have now the normals multiplied by the noise. Let's also create the vertex. Let's assess actually our vertex position that is contained in the variable gl vertex. So let's actually say I coordinate vertex. So a vertex in I coordinates, like exactly like the normals, is going to be equal to the GL model view matrix. This is the matrix that transforms the vertex into I coordinates multiplied by the GL vertex. So a vector matrix multiplication gives us another vector. This is a 4-component vector by default. These are built-in variables that we are going to see in the future. So now what we have to do is just to sum to the vertex, so he vertex plus equal to normal noise, and then we have to assign this as our GL position. So actually we need to transform this in projection coordinates, so in video coordinates, so we need to use the projection matrix and multiply this by the he vertex that we just created. Okay, and this should be good. There is an error, some error. Oh yeah, there is some. There is, of course, this is a vec3 actually, so we need to transform this into a vec4. We can just use the first 3 component of the normal noise, which is a vec3, and create a vec4 adding simply a 1 to the end. So the epsilon zeta components of this vector and the w component that gets used for some operations in the rendering pipeline, we can just set this 4th component, w component set to 1. This is good. Okay, so now the shape is being displaced using the noise. Let's, for example, change the dimensions of this noise, something like this, and now you can see that the vertices are being displaced according to the noise texture that we are sending to the object. As you can see, the light is not applied. I can also write lighting enable 1, but this is not going to change anything because the rendering parts that were responsible for the lighting are now being replaced by my shaders, so there is no lighting calculation anymore. We are actually taking place in this we are putting our program in between the creation of the shape and the rendering, so to create the light is up to us, but we will do this in a next video. What we can do is to pass a varying variable to our fragment shader. So let's create a varying variable called color. Let's make this a vec3, and let's assign to color, let's say that color is equal to our vec3 of noise. We can do this. Let's update. Let's close the vertex shader. Let's go into the fragment shader, and we have to create here another varying variable. So varying variable are variables that can be passed from the vertex to the fragment shader. So let's call this color, and then we can say okay. Let's create a vec4 as we did before, using the first 3 components from the color and just 1 for the alpha. And let's see what we get. An error. Program failed. Oh, okay, there is a syntax error somewhere. Probably is in the vertex shader. Everything seems cool. Yeah, everything seemed cool, but actually I deleted the square bracket. Yeah, this is how tough is to program in GLSL. It really doesn't forgive you anything. So let's create again our color variable. Of course, now there is an error because I deleted the varying here. I commented out the varying and also in the vertex shader. So this comes back now, and this should work. So now we have this kind of smoothed color that goes from white to black when the value is 1. So let's actually unpack. Let's actually jit unpack this matrix. Let's just visualize the first channel, that is the one that we are using in the shader. So let's take a look. This is how it looks like, and this is exactly how the vertices are being displaced and how the colors are being applied to every vertex and interpolated across the vertices. So so far so good. Let's actually make it a little more interesting by creating a jit.bfg object. So jit.bfg. Let's keep this one plane float 32, and let's make 200 by 200 passes. Noise point simplex, and let's create a send metro 1 here. So it should be a send metro 10, and receive a send receive metro 10, just because I use progressive numbers for every of my patches. This is why I put a 10 here. But then this should be rendered now. Yeah. Let's also create a counter, and it will also receive the metro. Let's actually make something like this. So let's first bang the counter and then the matrix out. So this also goes to the texture. So you see that this is already being displaced according to the noise. Let's animate that. So let's divide that by 100 to say. And let's use this as the offset to this texture. So $1, $1, let's use this as an offset both for the x and y direction. Now we are getting this displacement that goes smoothly according to the BFG function. Let's also use a scale, so we can scale this function and make it more, increase the resolution of this function. Yeah, that's quite nice. We can also change the basis. So let's pick the attribute basis here. Let's take a look. Let's pick, for example, noise cell that I quite like. Let's divide this for a smaller number so it gets a bit smoother. Not so much. Something like this. And you have this nice ever-changing shape, and this is all super fast because it's made with shaders, so you can actually have a really big shape and modify how many vertices you want using a shader instead of jit.gl. We could have done the same thing. I actually did the same thing in a previous video using jit.gl, but you can do this also in the shader and it will be more performant. So this was done using the GLSL editor. The next time we are going to apply also some light. So let's take a look. So with the light it will look something like this. Then we can apply also some post-processing in the fragment shader. Yeah, it's plenty of cool stuff. By the way, I updated the version of the GGL shader editor. Now lets you create multiple shader editor instance. Before it was a bit of a problem. So just download, if you downloaded it before, just re-download it now because I changed something and I will put this on the GitHub. Okay, so thank you for following, guys, and yeah, thank you very much, and see you into the next video. Ciao.